In this video, I will talk about how to design a base plate with axial load with moments, moment mx, moment my, moment in major axis and minor axis. So here I will start from the base, add new model. Here there are different type of connections. I am designing column base, and description you can put base plate design. Okay, if I have clicked, then randomly clicked, so you can go back in the edit. Here I came back in the same position, and if there is any left brace and right brace is present, then you can select, but in this base plate design, no. So here prismatic section, you can select W any section. For example, here I am selecting W 16, or maybe W16 100. Okay, and the material type you can also select the material. So here I am selecting A36 steel, 250 megapascal steel. Okay, so here are the material property and the section. Now I will go in the for example, loading condition, what types of loads are present. So here already dead load is defined. Now I will define another load. Here add a load case. Now you can also create snow load, wind load, earthquake load, XY. Okay, live load, its type, it's live. Okay, I'm clicking OK. Combination software automatically will create. I will discuss in the process of designing base plate. Okay, so here is a generate. When you will click generate, you can select how load combination will be generated. Here is different ASC 710 AST. Here I will select ASC, American Society of Civil Engineering 710 LRFD factor load combination design. Okay, I will click generate. Software will generate the load combination: 1.4 dead load combination, 1.2 dead load plus 1.6 live load combination. Okay, two load combination have been generated. Okay, you can go back and check. Yes, here software automatically created the two load combination D1, D2, two load combinations. Okay, for the applying of loads, you can go in the edit. Here is the loads. So what types of loads, you can see the notations, all things. For example, axial load, lateral load in two direction, in three direction, just like in normal calculation we do in our classes, that the x and y. So here that is 2 and 3 axis, that is 2 is the major axis, 3. So for example here shear to, for example M22. What is M22? Bending moment about minor axis. So 2 is a minor axis, 3 is a major axis about minor axis. So M33 bending moment about major axis, bending moment about 3 axis. Okay, minor is 2 and major is 3. Okay, so here I will apply the loads. For example, so first of all I have to make sure what unit system I am following. Here is the unit system SI. Units configuration SI, you can select. The load will be applied in kilonewton, moments will be in kilonewton meter, section will be in millimeter. Okay, so now I will go again in the loads. I will apply the dead load, maybe super dead load, that will be 50 kilonewton, live load maybe 100, and the moment I am applying that will be 35 in the M33, and M22 maybe you can select 50. So no need for in the dead load. I am deleting. I am providing in the live load, and you can select 40. So here you have applied the load patterns. Dead load, that is only axial 50 kilonewton, and live load, that is 100 kilonewton, and moment are 40 in M33 and M22. Software automatically put into the load combinations and calculate the values. I will also show how software calculated. Okay, so that's how you have applied the loading conditions. Now I will apply the boundary conditions like support condition. So further database sections, materials, connections, for example, all the database is present. Materials you can select according to your type. Connections, database, all type of connections, base plate. So here is a base plate connection types, bolts, welds, anchors you can study. So here I am going in the design. In the design I will here is the load ASA ISC 10 for the steel design code. So I will assign base plate connection. So our base plate connection is biaxial. Basically both moments are present, smart fixed biaxial base plate. So it will take some time and then it will assign. Here you can see the boundary conditions are assigned. So now I will just go in the edit, and click optimize. Before clicking optimize, here I will check the conditions. Here is the loads, dead load, live load. Here is a design combination 1.4 dead and 1.2 dead plus 1.6 live. Okay, biaxial, uniform, steel design code, concrete design code, complete area. So here is the optimization criteria. So what thickness the base plate will be designed. Here is a maximum thickness 76 millimeter and minimum thickness is 6.3. Software automatically apply the increments and design the optimum base plate. So similarly, base plate dimension, here is maximum distance to plate edge. Here is a maximum distance to plate edge. Okay, and next that is the effective embedment length from the base plate to the into the concrete. You can increase according to the code conditions. So here is a member, our member, prismatic member, that is a member type, that is a material. Here is a connector. So 3D. So I have not applied any stiffener, so you can apply and increase the thicknesses all type depending upon your requirement. So in this case I am just taking without any stiffener. So that is the unstiffened condition, that is a center. Okay, so you can also study that is a weld type. So basically we have to also fix the steel column to the base plate. For that is a weld strength E70. E70 means 70 KSI. That is a weld thickness, that is a 5 by हेलो
हेलो।
हाँ जिशान, मैं ठीक है, मैं ओके निकलता हूँ।
चलो ठीक है, ओके।
E70 mean 70 KSI. So here is a weld thickness, that is a 5 by 16 inch. So with pedestral means that is a concrete footing, that is a length and width. You can also optimize, I will also show. And the concrete, that is a material, you can also select according to your requirement. That is a 3000 psi, 4000 psi, 5000 psi. So here I am selecting 3000 psi. Okay, that is a anchor longitudinal position. If you want to increase the number of fasteners, you can increase the number of rows, anchors. And anchor type, that is a headed Here is a L bolt, here is a J bolt. So you can select according to your requirements. The bolt type, that is a hexagonal. Also you can, that's a very good option. You can also select if the reinforcement are you want to also consider, then you can also apply the number of reinforcements in the one direction and in the other direction. Similarly shear reinforcement. So now I will just click the optimize. Software automatically optimize the thickness, all the things. Here I will click optimize. In the results, all checks are almost okay. Here is the anchor's effective length. Maximum value is this, value is 345 millimeter. And second is elastic method weld axial capacity, means the weld thickness which is provided is not okay in the design combination too. So we have to see the thickness of weld length. Here is the weld length, the 3D. Here is the weld length given 5. I will increase into 6. Here you can see now the this is turning into green, means design check, or this base plate design is okay. So here I am clicking again, for example 4, it is going under failure. So now I will provide 6. Now our design is okay. For drawing, you can also generate the drawing from here. That is a top view, side view, and board, anchor detail. So that's how you will design into the in the RAM connection. So you can also export this drawing into DXF file. So that's all. Thank you.